And now, how am I sounding? Can you guys hear me? Is it great? You can do a sharp. So I'm looking at your screen right now. You can give me a thumbs up if I am audible enough and my sound is fine.
Yes, you are audible. I have a question because I received a timetable that says for STA1501 that I'm writing on the 13th of November. And I just heard now it's writing on the 16th, so I'm not sure which one is the accurate date.
You must go on my UNISA and check your exam date. They always post it on the platform.
All right.
Even when you log in onto your my UNISA, if you go to the calendar, they always put the dates there with your assignment. You should look there. You will have a link to your exam dates as well. Okay.
I received this one on my email. Okay.
Okay, so let's do basic probabilities. The times are very wrong. I'm going to skip them. So by the end of the session, you should be able to explain the key concept of the basic probability. You should be able to calculate the basic probability rules and calculate the conditional probabilities. So what is the probability? That's a question to you guys. Do you know what a probability is? Okay, the probability is a chance that something will happen. And when something will happen, that chance that something will happen, if it's going to happen, certainly, it will be equal to 1. And if it's not going to happen, which we call it the impossible event, it will be equals to 0. The probability of that event not happening is equals to 0. So I spoke about that if something doesn't happen, the probability will be equals to 1 or 0. And if it happens, the probability will be 1. What is that something? And that something is called an event. When an event happens, and an event is just an outcome of possible, an event. It's a collection of all possible outcomes that can happen. So for example, when I toss a coin, I am creating an event which is tossing, and the outcome that can come from there will be a head or either a tail. And when it's only one thing that I'm doing, like tossing a coin, that we call a simple event because there's only one thing happening at that time. Then we also have a joint event. A joint event can be tossing a coin and singing at the same time. There are two events that are happening, singing and tossing. When I have a coin has two sides. So one side of a coin is a complement of the other side. So it means a complement will be all events that are not part of the other side. So for example, I made an example of a coin which has a head and a tail. So a head will be a complement of a tail, and a tail will be a complement of a head. That's what complement events are all about. When you have all possible events that can happen, the collection of all of them is what we call as well a sample space. So remember, an event will be an action that happens that creates possible events, a possible outcome. A sample space will be a collection of all possible outcomes that comes from that event. For example, a die has 6 sides. So it means if I roll, I'm creating an event and the possible outcome that can happen will be either it will land on a 1, a 2, a 3, or a 6, something like that. And those we call them the sample space. When we talk about events, we can organize them in different forms in order for us to be able to visualize them and understand them. So for example, we can use my slide is not working. Sorry, I need to go back because it moved quickly. So when organizing the event, you can organize them in terms of a Venn diagram, and a Venn diagram will give you the sample space, which is a collection of all possible events. And within that event, there will be an outcome. And in this instance, I'm taking all days in a calendar for 2014. And I'm only interested in the days that falls on a Wednesday. And I put them in a block. Then I go and I look for those dates that falls on in January. So I put them in one block where they both overlap, which is this gray area here. Where they both overlap, those we call them the joint events. So the green one will be your simple event Wednesday. The orange one will be simple event. Yes, will be simple event January, and the green one or the gray one will be the days that falls in January on a Wednesday. And that's how you can visualize the event. The other form of visualizing the event is by using a decision tree, which is a tree diagram. It starts with your sample space, and when you create an event, you toss a coin, it can either fall on a head or it can fall on a tail. The next time you pick up that coin, if it fell on a head, when you pick it up, it can also, when you toss it again, it can fall on a head or it can fall on a tail. And this can continue and continue. And when all these are simple events, so this is a simple event, but the minute I toss again the coin, then it becomes a joint event. And this will be a head and a head. That will be the outcome. The other method of visualizing the probability or the events, you can use a contingency table. And I like using the contingency table because it makes it easy for you to see where your simple events are and your joint events are. And we will talk about them just now. Okay, so what is a simple probability? So a simple probability is calculated from simple event. So therefore it means your simple probability will be the probability of a simple event happening. So let's say, for example, we have that table that we saw earlier of the men and women who got promoted from this police force. And we can see how many men who got promoted and how many females who got promoted. We can see how many males who did not get promoted and the females that did not get promoted. From here, we are able to see clearly these are your joint event because it's a joint event of men and promoted. And the total gives you your simple event because promoted will be regardless of whether the person is a male or a female, there are 324. How then do we calculate this probability? So we will calculate the probability of promoted by using 324, and we will calculate the probability of men by using 960 because that is the simple event. But what is the formula? So calculating the probabilities, let's say we want to calculate the probability of promoted. The formula we use is the probability of a simple event is given by the number satisfying that event divide by the grand total. So it will be your X value. And in this instance, for promoted, it will be that X value is 324 divided by the grand total, which is 1,200. And that will give us the probability of promoted. I want you to calculate the probability of main. Calculate the probability of main. And you can post your answer in the chat. And Walbeck says is, are you Courtney? Courtney says is 0.8. Do you guys agree with her or him? I'm not sure. Are you a male or a female? Some other names are like Courtney. Help me before I refer you to a male, whereas you are a female, or I refer you to a female, whereas we are a male, or him. Okay, yes. Okay, so I see that the three sharp, it means 4 of 5. Okay, cool. You all agree? So the probability of main, if we write it here, probability of main will be given by 960 divided by 1,200. And when you calculate 960 divided by 1,200, you get 0.8. And that's how easy it is to calculate the probability of a simple event. Calculating the probability of a joint event, my PC today is very slow. I must apologize for it because now it's frozen. Oh, that's not on. Okay, so calculating the probability of a joint event, we calculate the probability will come, or to calculate that, we will use the joint event. So, which can be 2 or more events happening at the same time. And to calculate or to find the probability of a joint event, we use the probability of A and B. If A and B are 2 events, to calculate that the number satisfying the joint event divided by the grand total, which means we take X divided by N. So if we look at, we want to calculate the probability of men who are promoted. Looking at our table, it means we're going to look at men who are promoted. That is the event. And since the formula says is number satisfying the event, which is 288 divided by the grand total, which is your N of 1,200, then the answer we get is 288 divided by 1,200. It gives us 0.24. Calculate the probability of men and not promoted. Let's see how you answer it. Okay. So you, okay. Thank you. So you all say it's 0.56. So that is given by the probability of men not promoted is 672. 672 divided by 1,200 is equals to 0.56. We also have what we call the marginal probabilities, which are the same as your simple probabilities. These are just combining your joint probabilities to create a simple event. So we call them the marginal probabilities. And how do we calculate them? Just give my PC some second. Today's gonna be a long day. Like I had a long day, which started at 6 o'clock and it ending at that time. Okay, so computing the marginal probability or the simple probability, we use the joint probability. So if the table has 4 columns, then it's all the joint probabilities of that column to create that simple event, or what we call the marginal event. So let's see how we calculate the probability of promoted. Calculating the probability of promoted, we're going to use the joint event plus the joint event. So it will be the joint event divided by 1,200 plus the joint event divided by 1,200, which is 288 divided by 1,200 plus 36 divided by 1,200, and you will get the answer as 0.27, which almost exactly the same as the probability of promoted if we did calculate it earlier. Calculate the probability of women. Probability of women. Okay, say it's 0.2. Let's see if it's 0.2. So to calculate the probability of women, we take that joint probability and just joint probability, which is 36 divided by 1,200 plus 204 divided by 1,200, which if I calculate this manually, they have the same denominator, so it will be the same as 1,200, and it will be 36 plus 204, which then gives me 36 plus 204 gives me 240. 240 divided by 1,200, which then gives me 0.2. Great. We also have what we call mutually exclusive events. These are events that cannot happen at the same time. I need to go back because I can't see the chat now. Okay, cool. These events cannot happen at the same time. Let's say we want to choose randomly a day from 2014. And if we choose a day in January and a day in February, they both cannot happen at the same time. Therefore, event A and B will be mutually exclusive, because there will not be any day that will also be in February. We also have what we call collectively exhaustive events. Let me go back here because I didn't explain one thing. So these are mutually exclusive events. The probability that comes from mutually exclusive event, which will say if I want to find the probability of A and B, it will be equals to 0 because they can never happen at the same time. The other thing I need to also mention, when we look at the probability, sometimes they write them with the N. This is the joint probability, and we can write it as the probability of A and B. It still mean the same thing. The AND and the N, which is the union, intersect, and the AND mean one and the same thing. And if two events are mutually exclusive, therefore the probability of the joint event of those probability is equals to 0. Collectively exhaustive events are events that include all events of the sample space. So it covers the entire sample space. Let's say we have a randomly chosen day from 2014. A weekday, A represent a weekday and B represent a weekend. A and B will be mutually exclusive. But they will be collectively exhaustive if we're looking at a week. January is C and spring is D. A, B, and C, let's say A, B, and C are collectively exhaustive. A, B, C, and D. If I include all of them, there will be a day on a weekday and in a weekend. They can also be in January on a weekday and in weekend. They can also fall in spring on a weekday or in weekend. But January and spring happens in January? No, it happens in spring is in September, October. I don't know when spring ends. It doesn't end in December, because then it's summertime in December. I don't know. But yeah, they are collectively exhaustive. However, A and B are collectively exhaustive, and they are also mutually exclusive because they cannot happen on the same day. Okay. Let's recap on what we just did now so that we move into the rules. We looked at marginal probabilities and joint probabilities, and the marginal probabilities are just your simple probabilities. And we said we like to use a contingency table. If you have a contingency table, it's clear that you are able to see where you calculate your marginal probabilities or your simple events, and where you calculate your joint probabilities, which is represented by the purple area. Is the joint probability. The first one gives you the joint probability of A1 and B1. Okay. And the outside one, the green one, just gives you your simple probability or your marginal probabilities. if you add your joint probabilities. So what have we learned so far? That a probability is the likelihood of an event happening. I must also emphasize this. Probabilities are between 0 and 1. You cannot get a probability that is bigger than 1 or less than 0. The numerical measure, which is represented as a proportion. And if it's an impossible event, it will be 0. And if it's a certain event, it will be 1, where 0.5, it means there is a 50-50 chance of it happening. Like I said, it lies between, the probability of the sum, the probabilities are between 0 and 1. And the sum of all probabilities should be equals to 1. So, and this is only possible if and only if A, B, and C are mutually exclusive and collectively exhaustive events. Then they will be equals to 1. And we also learned that a complement of A is defined to be the event consisting of all points that are not in A. The probability of A will be 1 minus the complement of A. So if I have 60% or 0.5, if my probability of A is 0.5, to find the complement, which is the probability, I'm going to write at the top, the probability of A complement, I will just say 1 minus the probability of A, 1 minus the probability of A, which is equals to 1 minus 0.5, which is 0.5. Actually, I used the lame example. Should have used 60 or something, 60% or something, but you get the idea. To calculate the complement of that event, you just say 1 minus the probability of that event. Okay, I had an exercise which I actually did it for you, but you can, there's no harm in you doing this exercise while I go grab water. Where are we now? Let's see on the chat. 0.3, yes, you are right. But at some point, I'm going to stop talking and then you guys can talk and explain to one another. So this is the probability of rain, which means 1 minus 0.7, which is equal to 0.3. Now we move on and look at the addition rule. So what is an addition rule? And addition rule is the probability of either one event happening or the other one happening. Either or. So the probability of A or B, and with this as well, the probability of A or B, we can also write it as the probability of A union B. One and the same thing. The probability of A or B is given by the probability of A plus the probability of B minus the probability of A and B minus the joint probability. And that is the formula you use. So if the question says, what is the probability of A or B happening? You will say it's the probability of A plus the probability of B plus the minus the probability of A and B, because inside of A and inside of the probability of A, there is also the probability of A and B included in there, because remember, these are marginal probabilities. And I will show you at a later stage. However, if A and B are mutually exclusive, so if they tell you that even A and B are mutually exclusive, then the probability of A and B will be equals to 0, and the probability of A or B will be equals to the probability of A plus the probability of B. Do you understand? You can give me a sharp so that I can see that you understand what I'm saying. Only if and only if they tell you that event A and event B are mutually exclusive, then the probability of A or B will be the probability of A plus B. Otherwise, if they don't mention mutually exclusive anywhere, the formula you use is the top one. So let's look at the examples of doing this. Let's calculate the probability of men are promoted using the table. The formula you remember is the probability of A or B, which is given by the probability of A plus the probability of B. So if you look at this whole thing, you will see that when you calculate the probability of A, so our A, let's say our A in this instance is men. So if you take men and you're going to calculate the probability of men by using 960, you will see that it includes 288. If you calculate the probability of B, which is promoted, if we take promoted, you will notice that it also includes 288, and that is why there is that minus there. So it's part of the equation. So we're going to calculate it by saying 960 divided by, because these are events. Remember, when it's a whole number, it's an event. So when we calculate the probability, we'll say 960 divided by 1,200, and we take 324 and divide by 1,200. And that will give, and minus 288 divided by 1,200. And that gives us 0.83. Also need to pay attention on this. When it's whole numbers like this, you must know that these are events. If it's 0.6, 0.3, 0.8, you must know that you are given probabilities. You just need to substitute into the formula. You don't have to divide by the total. You just substitute the value you see onto the formula because it's already in a decimal form. So it's a proportion. Okay, so I explained this. It's just that my slides are very delayed when I click. Like now, we have to wait. Like the, okay, so I think it went too quick, okay. Now you have an exercise. With this exercise, I'm going to take you through step by step. So the first part, let's say, I haven't given you the question as yet. I'll give you the question. If the probability of A is equals to 0.4, the probability of a B complement is 0.5 and the probability of A and B is equals to 0.1. So they give you all this information. And the question they're asking you is, let's say this is option number 1. It says what B probability of B is this 0.005. So you are looking for the incorrect answer in the exam in that format. So in here, just want you to give me the answer. Find the probability of B. You can say it out loud. You don't have to type it on the chat because it's the easiest one. How do we find the probability of B? And they post on the chat. And Courtney says it's 0.5, but I wanted someone to tell me how to find it, but it's fine. Oh,
the probability of B is 1 minus the probability of B complement.
Thank you. Yes. Good, gooder, goodest. So the probability of B is 1 minus the probability of B complement, which is equals to 1 minus 0.5, which is equals to 0.5. What will be the probability of A or B? For now, I'll give you the formulas. The probability of A or B is given by the probability of A plus the probability of B minus the probability of A and B. You got it? Oh, you're still busy calculating. Remember, you are given the probabilities, you just substitute into the formula and calculate. Okay. Tamarin says it's 0.8. How do we find 0.8? Anyone? To find 0.8, we say 0.4 plus, we calculated the probability of B, which is 0.5, minus the probability of a joint probability, which is that. Don't get confused with my N is the same as N. Remember that? This is the same as N, which is intersect 0.1, which is equals to 0.4 plus 0.5 is 0.9 minus 0.1 is 0.8. That's how easy it is. To find the probability of A or B. The last question, I'm going to remove this 0.8 here. Just give me a sec, because there is a last question. If A and B are mutually exclusive, what will be the probability of A or B? If A and B are mutually exclusive, find the probability of A or B. I'm not going to give you the formula.
Zero.
The probability of A or B, you must repeat the same formula, but what else? Okay, who wants to help out on this one? The probability of A or B is given by the probability of A plus the probability of B, which is 0.4 plus 0.5, which is equals to 0.9. Must remember, if they say A and B are mutually exclusive, then the probability of a joint probability, which is the last bit, will be equals to 0. Okay, I am going to give you guys it's 1753. I'm going to give you just 2 minutes, or let's say 5 minutes. Let's meet back at 6 past 5. 6 past 5. Then we will do conditional probability, which is the last bit of the session. You can take a break.
I was looking for sugar.
I need to make coffee.
To make tea. You finish the sugar.
Is everybody back? If you are back, then let's continue. Please remember to also sign the register. I'll post the link again if you haven't completed the register. It's somewhere in the chat. So let's continue and look at the conditional probabilities. If I recap on what we did so minutes ago, so we looked at the additional rule where we said the probability of A or B is given by the probability of A plus the probability of B minus the probability of A and B. And if A and B are mutually exclusive, then the probability of A or B will be equal to the probability of A plus the probability of B. So going forward, looking at the conditional probabilities, we're going to look at 3 areas. We're going to look at the basic concepts around conditional probability. Then we're going to look at when the events are independent, what happens to those conditional probabilities. And also the last one, we will look at the multiplication rule because they are all linked to one another. So what are conditional probabilities? A conditional probability is the probability that an event will happen given that another event have already happened. That's a conditional probability. The probability of A, given that the probability of B occurred, is given by the probability of A and B divided by the probability of B. And this, we call it the conditional probability of A, given that the B has occurred. And we can also do interchange. The probability of B given A is the same as the probability of A and B divided by the probability of B, of A, sorry, of A. And this will be the conditional probability of A given that conditional probability of B given that A has occurred. Where the probability of A and B are your joint probabilities, remember that. So it will be the joint probability of event A and B divided by the given probability. And the probability of A will be the marginal probability or simple probability of A, and the probability of B will be the marginal or simple probability of B. Let's look at an example. If we want to calculate the conditional probabilities, let's say we are given this statement. It says of the people hired, 27% have been promoted. So this will be your simple event promoted. 80% are men. That means the probability of simple event men, and the 24% are both men and promoted. To take this information that we are given, we can also, my laptop is frozen, we can also represent it on the contingency table, because we know we have the simple probability of promoted, and we also have simple probability of men, and we can put the simple probability of 24 there, and we can quickly complete the whole table. So completing the whole table will mean taking 0.27 minus 0.24 will give us 0.3. 0.8 minus 0.24 will give us 0.56. So already I have those values there and those values there. Coming this side, I know that the sum of all probabilities are equals to 1. 0.2, if I subtract it from 1, which it will mean 1 minus 0.27, it will give me 0.73. Then I can also calculate this value because I have 0.56 from my previous 0.8 minus that, it gave 0.56. So to calculate this area, I say 0.73 minus 0.56, it gives me 0.17. Then my whole table is complete. And for this one, I can add all of them. And I can add 0.03 and 0.13, and it will give me 0.20. Or I can take 1 minus 0.8, it will give me 20. It doesn't matter how you complete the whole table, but you can complete the whole table when you are given only 3 values. As long as they give you the joint probability and the simple probability corresponding to that joint probability, you should be able to complete the contingency table. Let's look at an example. If I need to calculate the probability of A given B, in this instance, let's say in terms of the table that we are given, the probability of men given promoted. So I'll go and find the probability of men will be 0.8. Oh, sorry. I am calculating the probability of men given promoted, which is given by the probability of A and B divided by the probability of B. So the probability of the joint probability of men and promoted will be, the probability of men and promoted will be 0.24, and the probability of B will be the probability of promoted, which will be 0.27. So I take 0.24 divided by 0.27, then it gives me, oh, sorry, my bad. Then it will give me 0.89. Any question? Anything that you don't understand? Can I do another example? Let's do another example. Let's say we want to find the probability of women not promoted. What will be the probability? The probability of women, given that none of them are promoted. And that will be given by the joint probability of women and promoted, which will be the probability of women and not promoted, divided by the probability of not promoted. If I go to the table and I look for the joint probability of women and not promoted is 0.17. Then I need to find the probability of not promoted, which is 0.73, 0.73. And that will give us 0.17 divided by 0.73 equals 0.23. 0.23. What if I want to find the probability of promoted and women? What will be the probability of promoted and women? To find that, we need to find the probability of promoted, given that, the probability of promoted, given that the person who was promoted is a woman. And that will be given by the joint probability of promoted and women divided by the probability of women. And the probability of promoted and women is 0.3, 0.03 divided by the simple probability of women, which is 0.20, 0.20. 0.03 divided by 0.20 equals 0.15. Equals 0.15. And that is the conditional probability. Okay, when we look at the multiplication rule, Me too. Unless if you have a question. Nobody has a question? Okay. If there are no questions, then we move on to the next part, which is the multiplication rule. Multiplication rule comes from your conditional probabilities. Let's write it back, the conditional probability. Remember, the probability of A given B let me write it nicely. The probability of A given B is given by the joint probability of A and B divided by the probability of B. Remember that? That's what we did. Now, let's say in the exam, they give you the probability of A given B and they say it's 0.1. And they also give you the probability of B, they say it's 0.2. You need to be able to use the information you get and solve for what is missing, which is the probability of A and B is missing. And if A and B, we want to make it a subject of the formula, what do? We multiply the probability of A given, multiply by the probability of B. So you just take that to the side because it's in the division. When it comes this side, it multiplies. And the probability of A and B will be given by the probability of a conditional probability to multiply by the probability of B. And that is the multiplication rule. If and only if they tell you that event A and event B are independent, then the conditional probability of A given B is equals to the probability of A, because it means B has no relation to A and B does not influence what happens to A. So the for independent events, if A and B are independent, then the conditional probability of A given B is the same as the probability of B. Then it means for multiplication rule, the conditional probability will be replaced by the probability of A for independent events. Then your multiplication rule will state that probability of A and B will be equal to the probability of A multiplied by the probability of B. And vice versa if we have B given A. Let's assume this is one of the exam questions. It asks if B is equals to 0.2, what will be, and the probability of A complement is 0.7. And the probability of A given B is 0.9. What is the probability of B given A? The first step you need to do is, with this question, is to write the formula for probability of B given A to see what you are given, can it fit into this formula? So the probability of B given A is given by the joint probability of A and B divided by the probability of A. That is the standard formula that we follow. We always divide by what is given at the second part. So the probability of A and B divided by the probability of A. If you look at the question or the statement that you were given, do I have the probability of A No, I don't have it. So if I don't have it, then it means I must calculate the probability of A. And that's what I expect you to calculate right now. And then we'll move step by step by step. At the moment, calculate what the probability of A is. And then we will move to the next step. Remember, the probability of A, you can find it by using the complement of A. You're making my life difficult by posting on the chat and not talking to me, but it's fine. Roslyn says it is 0.3, and that's 1 minus 0.7 gives us 0.3. So now we have the denominator. We need to find the numerator, which is the probability of A and B. If I look at the statement that I'm given, I am not given A and B, but you are also given the probability of A given B. So you need to know that if I'm given the probability of A given B, it means for me to find that, I derived this probability of A given B. If I write it in a formula, it will be the probability of A and B divided by the probability of B. If I look at what I am given, sorry, my voice, I've been talking the whole day. Like I said, I've been talking since from 6 o'clock in the morning until now. It's not normal for somebody to talk like that in these meetings. So my voice is taking a toll now. The probability of A given B, we are given it's 0.9. The probability of A and B, that's what we need to find. And the probability of B, we are given. So the next step in your journey to answer the question of finding the probability of B given A, you have to find the probability of A and B using that formula. All the information is given. You just need to find the probability of A and B. So you will find it by using the formula, the probability of, why am I writing at the top? You will use the probability of A given B, because it's a multiplication rule. You will multiply by the probability of B. Are we winning? Oh, my voice is dying, guys. By 30 minutes, if my voice is still here, you will be lucky. If not, I don't know how we're going to conclude the session. It's definitely dying. And Courtney, he says it's 0.18. So substitute the values into the formula. The probability of a given A given B is given to us by 0.9 multiplied by the probability of B, which is 0.2. It's also given into the formula, 0.2. And all this will be 0.9 multiplied by 0.2, which is 0.18. Which is 0.18. Now we need to find our probability of B given A. So you already have the the formula at the top. Just use that formula and substitute all the values that you have. You have the probability of A, you have the probability of A and B. Sorry about that. Okay, I see you. Guys, can you help me? Because I won't be able to conclude the session. You need to start helping me to explain the exercises so that I can save my voice.
So to get the final answer, we use the answer that we got for the probability of A and B, which we got 0.18. We'll divide that by the probability of A, which we calculated is 0.3. So 0.818 divided by 0.3, you get 0.6.
Agree. Do you have any question? Anybody who has a question? If there are no questions, I hope this is the last slide. Then you do the exercise and I can keep my voice calm. Okay. For independent events, if only and only if they tell you that event A and event B are independent sometimes, then you can use the formula. But sometimes they will ask you to confirm if event A and event B are independent. So if they don't tell you anything, but they ask you, are event A and B independent, then it means you need to go and validate that answer by calculating the probability of A given B and checking that that probability of A given B is the same as the probability of A. Or you go and calculate the probability of B given A and go find if that probability is the same as the probability of B. And if they are equal, therefore it means the two events are independent. And with that, I am going to save my voice because I'm going to ask you to try and answer this question in the next 2 minutes or 5 minutes or so. Then we will do more exercises later on. The question is asking you, using the previous answers that we got, let's go back to the previous answers. You remember the previous answers you got? These are the previous answers you got. The probability of B given A, you know what that is. The probability of A, you know what that is. And the others, they are given to you in the statement, which is the probability of B and the probability of A given B. Using the very same statement, answer the following question. Are event A and B independent? Number 2, are event A and B are mutually exclusive? You still remember what do we mean by mutually exclusive events? You must, if you forgot, you must go look at the what is this probability and what the answer is, and go back and refresh your mind in terms of the mutually exclusive events. Events cannot happen at the same time. No answers? Okay. Let's do it together. Remember, for independent events, we need to check if the probability of A given B is equal to the probability of A. Or you can check that the probability of A given B, what am I writing? Of B given A is equal to the probability of B. So we can start with the answer that is in front of us. We can use that because we know what the probability of B is, and we know what the probability of A and B are. But we need to know what the probability of A is so that we can compare it to this figure. We did calculate that. So we know that this is 0.9, the probability of A and B. And we've calculated the probability of A from there, and we said it's 0.3. So these are not equal. Therefore, event A and B are not independent. You can even go and check the second part where it asks the probability of B given A, if it's the same as the probability of B, which is 0.2. Based on the answer we got previously, the probability of B given A was 0.18. If I remember well, I can go there and check. Oh, it was 0.6. It was 0.6. 0.6. And the probability of B is 0.2, and they are not the same. So it means they are not independent. Are event A and B mutually exclusive? The probability of A and B, we calculated it and we found that it was 0.18. Therefore, oh, sorry. It was 0.18. That was that probability that we got. Therefore, it is not mutually exclusive. Why? Because the probability of A and B is not equal to 0. It's not equal to 0. And that's how you do the exercises. In the next 30 minutes, I'm going to give you more exercises to do And the first exercise that you need to do is that one. The table is incomplete. You will have to complete it. And once you have completed it, you need to calculate the probability of neuropsychologist and boy, which is the joint probability. So you will have to calculate your X divided by N, the joint probability of neuropsychologist and boy. But before you do that, you need to calculate the grand total. How much is the grand total? Do we have an answer now? Did you calculate the whole table? What is the grand total?
It's 220.
It's 220. Do you all agree? So what is the joint probability of neuropsychologist and boy, which is 45? Then you will say 45 divided by 220. What was the answer? Do we have an answer? You can say it out loud.
0.25.
0.205.
0.2. Yes.
sorry, 0.205, which makes option number 5. I hope you completed the whole table because the next question also asks the same question. Oh, no, it doesn't. This is asking the probability of neuropsychologist or a boy, which is given by the probability of neuropsychologist plus the probability of boy minus the probability of neuropsychologist and a boy. So you should have completed the whole table so that you can have the probability of neuropsychologist there, and you are able to calculate the probability of boy by using that value there. And the first one, we already calculated it previously, so you don't have to recalculate that. And remember, you are given the event, so you need to calculate the probabilities. How do you get 220? Nadine, you have to complete all the missing information pieces. So if you add 90 plus 45 plus 30, it should give you the answer in the red cross on this red cross there. If you add all of this, should give you that circled red cross. Then if you add the red cross plus 55, it should give you the grand total here. And that will be the 220 that we have. Then you also have to complete this whole set. So you say this plus this will give you that. This plus this should give you that. And that, because you don't have the answer for this one, you can take the 220, subtract that plus this from 220, it will give you that value. And you use this value to subtract 30, and so that you can get this value. That is doing it step by step like that. Let me repeat again so that you understand how to get it. The easy way is to calculate 90 plus 45 plus 30. It will give you this value here. Tell your dad to switch off the car radio. Then the other way, then you add these two so that you can get the grand total there. Once you are done, the next step you can do is you can add this value and this value and subtract them from 55. That will give you the value here that is missing. That's another way of doing it. When you're done, you would have completed the blockies in here. Then you are left with those blockies outside. You say 90 plus 30 will give you the answer there. 45 plus 15, it will give you the answer there. 30 plus the answer you got from here, it will give you the answer there. And then you will see how we got to 220. Are we winning on the second one? I saw. Please, guys, talk to me. I see there are two answers. Are these answers for the second one or the first one? Talk to me, talk to me. If I go back, okay. So we agree that this answer is 220, which is 90 plus 45 plus 30 equals 165 plus 55 equals 220. That's how we got to 220. So it means this one is correct. The second one, remember, you are given events. So you can use the events, or you can use this last one. You can use the probability we used previously. What will be the probability of N over neuropsychologist, which will be the answer on here, which is 45 plus 15, which gives me 45 plus 15 is 0 plus 156, which is 60. And if I add all this, I get 165. So it means the probability of neuropsychologist will be 60 divided by, remember here it's 220, guys. So that will be 220 plus the probability of boy, which is 165 divided by 220 minus, I can also do the same because it's addition and subtraction, so I'll work from left to right, it's fine. Or I can use the value we got from the previous one, which is 0.205. If not, if I want to do it all at once, I don't have to do this. Then I can say the joint probability, which is 45 over 220. And remember, they are all the same denominator. So it's the same as 60 plus 165 minus 40. You can do it in that way, which is 1 of 60. So that will be 60 plus 165 minus 45 divide by 220 because they've got the same common denominator. And that will give us 60 plus 165 minus 45 gives us 180 divide by 220, and the answer you will have will be 0.818, which is option 2. Let's see what you do. What did you do? What did you do? Okay, Roslyn got it. I am not sure if Denise and, okay, no, she did it twice now and the answer is still not the same. So the answer will have been option number 2. Okay, the next question. This might take us longer. Let me give you a hint because it's 10 to. It says, if you are given the table, which one of the following statement is incorrect? The probability of social media, the probability of complement of social media is the same as the probability of traditional media, which is equals to 0.25. The probability of celebrity and the probability of sports star. Simple probabilities, simple probability, simple probability, simple probability, all of them. So it means you're going to use the simple probability will be the values at the total. So quickly calculate 1, 2, 3, 4, 5. When you do 5, when you do 2, because you would have calculated 1 and you would have the answer for 1, you just need to calculate the probability of TM and see if they both are equal to 25. The probability of celebrity, you just need to make sure that you calculate the, but also, wait, sorry. This, they are on the same side, so they can never happen at the same time. If TM was on the other side, then they could, but I'm not giving you the answer to this. I just want to see if you know what you're doing. Then the rest, you do simple probabilities for all of them. So let's wait. I'm gonna give you 5 more minutes to do this one. And I had the last one, but we ran out of time. Okay, maybe I can do this one. So the probability of social media, which will be 305. So that will be 315 divided by 4,000. If it's the same as this, then it's correct. The probability of a complement of social media will be 3015 divided by 4,000 equals 0.75. 0.75. The complement of social media, complement of this will be 0.25. We need to calculate the probability of traditional media, which is TM, which is equals to 985 divided by 4,000. And that gives us 0.25. So this will be correct, that will be correct. What is the probability of celebrity? Because they're not saying it's mutually exclusive, so I made a mistake in the beginning. They are saying they are equal in terms of they are all equals to 0.25. The probability of celebrity will be 285, 2285 divided by 4,000. 2285 divided by 4,000 is 0.57, which is correct. The probability of sports star, which is 665, which will be 665 divided by 4,000. 665 divided by 4,000 equals 0.7, which is equal, the same. So therefore it means none of the above questions will be correct. With the next 5 minutes, try and see if you can answer the joint probability and the conditional probability. Do we have an answer? At least. Okay. Let's see. What did you say on the chat? Nothing. You guys not talking to me. Okay, so how do we answer this? Both of these are the three, option 1, option 2, option 3 are joint probabilities. The first one, it says celebrity and sports star. So the joint probability of celebrity and sports star can never happen. So that will be correct because they should be equals to 0. The next one, it says the celebrity and social media. The joint probability of celebrity and social media is 1800 divided by 4,000. And the answer you get is 1800 divided by 4,000. You get 0.45. That is correct. Celebrity and traditional media is 485. 485 divided by 4,000. What do you get? 485 divided by 4,000. You get 0.12. 0.12. This was 0.45. Ne? So this is correct. Now we need to calculate the conditional probability of social media and celebrity. Now, I'm going to write it here. The probability of social media given celebrity is given by the joint probability of social media and celebrity divided by the probability of celebrity, which is, what is the social media and celebrity? We calculated it previously. We said it's 0.45. Divide by the probability of celebrity. We calculated it previously there in the past question. It was 0.57. So I'm going to use that, 0.57. And this gives us 0.45 divided by 0.45 divided by 0.57 equals 0.79. 0.79, which means this is incorrect, but I can just double check the next one, which is the probability of social media and sports star, which is given by the probability of social media and sports star divided by the probability of sports star. And this is given by the joint probability of social media and sports star We didn't calculate that, which means it's this 515. I can calculate it. 515 divided by 4,000 equals 0.13, which is 0.13 divided by the probability of social media. And the probability of social media, we calculate, oh, sorry, the probability of Sportstar, we calculated it previously. Probability of Sportstar, we found that it was 0.17. Is that the right one? Let's go back. Yes, PSS, which is Sportstar, is 0.17. That will be 0.17. So 0.13 divided by 0.17, it should give us 0.6. Here they have 0.77, but I think that was correct. And that's how you answer the questions when it comes to the probabilities. I'm going to recap just now. While I recap, please make sure that you complete the feedback form. Those who haven't completed the attendance register, don't forget to complete it. I am pasting the feedback evaluation form on the chat. Make sure that you complete that. And to recap on what we just did, we looked at the basic probabilities. We unpacked the concepts relating to the basic probabilities when it comes to events, that we have simple event and joint event. And when we calculate the simple event probability, we use the simple event. It's your observation satisfying the simple event divided by how many there are. For a joint event, which means two events happening at the same time, when we calculate the probability of joint event, it means we're looking for observation satisfying the joint event divided by how many there are, which is your grand total. Then we looked at concepts like mutually exclusive events, which means events can never happen at the same time. We also looked at collectively exhaustive events, which are events that include all of the sample space. So going back to the mutually exclusive event, we learned that the probability of mutually exclusive events is equal to 0. Then we also learned that the sum of all probabilities is equal to 1, and the probabilities are always between 0 and 1. We also learned that a complement event of a probability of A event A is the same as all events that are not included in A. We moved on and we did the addition rule, which is the probability of either one of the event happening. So, and that is given by the probability of A plus the probability of B minus the probability of A or B. And we also said if event A and B are mutually exclusive, then the addition rule will state that the probability of A or B will be given by the probability of A plus the probability of B. Then we also moved on and looked at the conditional probabilities. With conditional probabilities, we said the conditional probability is a probability that is happening given that another event already happened. So probability of A given that B has already occurred is given by the joint probability of A and B divided by the probability of B. We also learned that the opposite, where if it's the probability of B given A, it will be the probability of a joint event of A and B divided by the probability of of A. But we also learned that if and only if they say event A and B are independent, then the joint probability or the conditional probability of A and B will be the same, given A given B will be the same as the probability of A, because then B does not have any bearing on what happens to A. We also learned about the multiplication rule, and we said with multiplication rule is just if they give you the probability of given and the probability of simple event, then they're asking you to find the probability of A and B. you can use the multiplication rule from your conditional probability, which will give the joint event of A and B will be given by the probability of A given B multiplied by the probability of B. And we also said if and only if event A and B are independent, then the probability of a given event will be the probability of a simple event. Remember that. So then it means in terms of the multiplication rule, the probability of A and B will be given by the probability of A multiplied by the probability of B. And that's all what we learned only for today. I will see you next week, Thursday. But before you leave as well, I want to encourage you, because I know that we're running way behind schedule. I always have sessions on a Friday night and a Saturday night for my online tutorial classes. We are way ahead of everything. I'm going to post the link to those recordings. Unfortunately, I cannot invite you to those sessions, but I can, I will send you the links to the recordings that we already had so far, because up to today, up to now, we have completed all the content. This coming Saturday, we are doing the linear regression only on Friday. So I'm going to send you the link now. Don't leave as yet. Before I copy the link from I must still go to the website to get the link. Just give me a sec. Otherwise, if you have any question, feel free to post it or say it out loud. Would the recording be available for this session? I know that the recordings will be made available, but I don't know when. So that is why I'm going to give you the link to my private site that has the e-tutorial for my e-tutor classes, because I run the online site, the online sessions for them. Then I post them on my UNISA, but I also post them on the private site for anybody who wants to visit what we have done in the e-tutorial class, so that then you can also use that those recordings to complete your assignment, which is due tomorrow. Just give me a sec. It's still opening. Like I said, my site is, but my, what do you call this thing? My website is very slow, or my computer is very slow. Just bear with me, bear with me. I will be there with you just now. Just want to I need to give you the right site, which is this one. Then I must go to, and this is also applicable for those who are doing 1501 and 1610. Everything will be under the 1610 module, but there are the content is the same. So the same videos I go through with you, I also go through them with them. So you will notice that we have all the chapters up until chi-square. Okay. If there are no questions, I'm going to stop the recording now.